Hello, everyone. This is Jiang from Rogers University. So, as the chair mentioned, because the author cannot make it to US, so I'm just here to help him present this paper. So let's get started. So today I'm excited to present this work, Sync+Sync, a Covert channel built on fsync with storage. So as we all know, as computer scientists have long explored various Covert channels to collect information, often focusing on the CPU cache and the memory as the primary building blocks. And since programs share these resources when running concurrently, in our research, we dive deeper into the memory hierarchy, particularly into the persistent storage and file system, to uncover the novel Covert channel. So our investigation centers on the synchronized L operations using the fsync system call, which is an unprivileged command that user space programs use to synchronously flush the data to the storage device, which can ensure the data persistency in an orderly manner. So many applications extend fsync operations latency within file system, and a problem that can be even worse when multiple files even fsync simultaneously. So let's imagine two programs, A and B, both executing fsync after certain operation on the same disk. While program A performs fsync, we measure its latency, and we found that remarkably, when program B is simultaneously calling fsync, program A's latency will be increased to more than double. So this significant delay is caused by contention at multiple levels within the storage stack. And the program running within the same file system shares its data structure as well as the storage device. So for instance, in ext4 file system, only one transaction can be processed at a time, causing fsync operation to wait for previous transaction to complete. And moreover, concurrent fsync operations often compete for other limited software and hardware resources in storage device. For example, the BIO and the disk driver layer must serialize and write down data through the IO queues. So consequently, even programs running on different disk partitions, even with its own file system, can largely impact one another's fsync performance. So given the 2 times difference, it's a good base for building a timing-based channel. So let's first make a Covert channel. As we need fsync at both sender and the receiver, we call it Sync+Sync. So the sender transmits a bit by either calling fsync or not, while the receiver will decode this bit by calling fsync. So for instance, a longer response time for a receiver indicates a 1, and while a shorter response indicates 0. So we have demonstrated that the Sync+Sync Covert channel achieves transmission bandwidth of like 20K bits per second with an error rate of around 0.4%. So particularly in the cross-file scenario, Sync+Sync can effectively work across files, containers, virtual machine, and even across different partitions. And furthermore, Sync+Sync is functional on both SATA SID and NVMe SID. Now let me introduce the side channel attack made possible by Sync+Sync. So in practice, many victim applications such as database, Linux, Android apps, and web browsers use fsync to securely store data. And we can use Sync+Sync to extract sensitive information from a victim application by analyzing its fsync call over the time. And as an attacker, which situates on the same disk but using irrelevant files, can periodically invoke fsync to observe the victim's behavior. So through our research, we discovered that different applications have distinct fsync calling patterns in terms of frequency and the volume of data to be flushed. So these differences in fsync latency can be censored by the attackers, allow the Sync+Sync to distinguish between different applications. So we utilize SQLite as our victim database, which employs undo logging. So SQLite invokes fsync when committing the transaction. And as illustrated in this diagram, by leveraging the Sync+Sync side channel, the attacker can detect the longer fsync latencies when the victim database synchronizes the files. So this ability enables Sync+Sync to classify and identify the database operations like insert, updates, and between node split in SQLite. We also applied Sync+Sync to differentiate across patterns between common applications and a website. So for instance, attacker can accurately distinguish between Facebook and Twitter with 100% accuracy by analyzing their error trace. And the Sync+Sync offers an effective tool to observe a victim's error pattern. As for the website fingerprinting, while most websites do not frequently use fsync, making them difficult to distinguish, use Sync+Sync. Like some websites like qq.com and signa.com.cn do this thing. And these websites invoke fsync more often due to their use of the index database for persistent storage and making them easier to recognize with Sync+Sync. And in the keystroke attack, for every keystroke tapped by the victim, the service program auto-commits the user input by storing it in a file with fsync. So in order to persistently track the user's latest input, this means a keystroke is followed by fsync. So in the meantime, the attacker performs the Sync+Sync attack by continuously invoke fsync to infer whether user input is stored by measuring the attacker's fsync latency. So giving a stored user input, the attacker can detect an increased fsync latency. So consequently, if the fsync latency remains low, the attacker deduces with a high probability that no user input had been sent to the service program. So this figure illustrated a back-to-back comparison of the inter-keystroke timing between the reference tappers and Sync+Sync attack. So this difference underscores that Sync+Sync successfully detects keystroke with 99.2% accuracy. And due to the inter-keystroke latency being much greater than the attacker's fsync latency. So to conclude, we have presented Sync+Sync, a timing-based Covert channel built on top fsync system call in persistent storage. And to our best knowledge, Sync+Sync is the first Covert channel that make use of fsync at the persistent storage without sharing any data between sender and receiver. And our experiment shows that Sync+Sync achieves transmission bandwidth of 20K bits per second with an error rate of about 0.4%. And it operates effectively across various configurations, including like cross-pattern, cross-file, and cross-containers. We also test its robustness by introducing various noise vectors, and we applied Sync+Sync to execute side channel attackers on real-world applications, which successfully classify database operations and distinguish between different applications and websites based on their fsync behavior. And we even demonstrate the flexibility of a keystroke attacker with high accuracy. And you can find the full version of the paper and the source code of the Covert channel at this link. So, and thank you for your time. This is the TOS lab in ShanghaiTech, and you can check their website for more information. And for all the questions, just feel free to send an email to the authors. And I'm on the job market. I'm working on computer system and storage. Thank you.